stream up and running now. Yep, we are live and we are recording. Okay, we still have people dropping in, but we will begin in just one moment. Welcome everybody. We're just letting a few more people who are showing up into the lecture. West and Leo, if it's okay with you guys, I will I'll hand over the admit duties to you all, and
Great.
I will get started.
Thanks, Ed.
Okay, thank you very much, folks. So, good afternoon, everyone. From New York, it's 1:05 p.m. here. I assume some of you are signing in from around the world, so thank you so much for joining, and welcome to the second lecture of the Overview Effect lecture series. I'm Ed Keller. I'm the co-director with Carla Leitao of the Post-Planetary Universal Design Program at the New Center. And this year, I'm also a creative director of the Space and Planetary Design track for the Venice Architecture Biennale underneath the Italian Pavilion and the Italian Virtual Pavilion. The Italian Pavilion is curated by Alessandro Mellis, and the Virtual Pavilion by City X Venice, Tom Kovac. So many thanks to Alessandro and Tom, their teams, for making this all possible. Thank you also to the brilliant designers and thinkers who are joining this extended series of exhibitions, events, lectures, symposia, and performances, which are being made possible by the Italian Virtual Pavilion in the Biennale this year. The Overview Effect lecture series is the first set of talks in the Space and Planetary Design track, which I'm convening and curating this summer and fall. It's positioned as a survey of some of the key operational themes critical to what we could call post-planetary and universal design. It brings together an architect, engineer, historian, Lydia Kallipoliti, who spoke yesterday, an AI developer, mathematician, philosopher, Ben Goertzel, who's our guest today, a science fiction author and marine biologist, Peter Watts, who's joining us next week, and a transdisciplinary geographer and ecologist, Stephanie Wakefield, who's also joining us next week. And through this group of interdisciplinary thinkers and builders, we're engaging the question of how disciplinary boundaries can be effectively and critically reshaped towards a universal modality of design thinking. We also are featuring some special guests each week. Yesterday, Fred Sharman, the historian and architect, joined us for a conversation with Lydia. Today, the New School Policy and Design for Outer Space group will join us for a conversation with Ben Goertzel. The philosopher David Roden will join us next week to speak with Peter Watts, and we have a few more lined up to talk with Stephanie. So just a couple of words on this term, post-planetary and universal design. What are we working on by thinking through these implications? As architects, as urbanists, infrastructural designers, system thinkers, economists, ecologists, AI developers, artists, we navigate and negotiate with the intertwined webs of human energy expenditure and information flow, and their impacts on civilization and all species on Earth. The challenge for us is to envision new configurations at the edge of the planetary comfort zone. For example, architecture's conception of itself as a discipline has depended for centuries on a model of the artificial in relation to the natural and the primal human action in the wilderness. Do we build a hut or do we make a bonfire? This tension between codex of preservation or rituals of conflagration also configures the very base of organic and planetary life and the negative entropies of design. Thus, we could imagine design as a radically temporalized act. It functions as an amplifier or an attenuator for the planetary broad spectrum codex of our historical, material, organic, and socio-technical configurations. Our life world, our built environments, operate across a deep arc of temporalities, from the moment of a gesture or the life of a single organism, to the millennia-long presence of a building, a law, a city, an ecosystem, and the billions of years of our planet. So by analyzing, distilling, and synthesizing these arcs of time and scale, we try to project across and into alternate configurations of the past and the future, and attempt to account simultaneously for the limits of organism, building, mind, planet, and universe. A world remaking, unmaking, remaking, writ both small and large. And we chose the overview effect as a concept, a rubric under which to operate for these first 4 lectures, because it describes a shift in cognitive perception of scale and value, famously attributed to what astronauts sometimes experience when they're orbiting the Earth or looking back at the Earth from the moon, famously also riffed on by Joni Mitchell in one of her songs from the 70s. And so we imagine the different vantage points and points of view that might be necessary for a collective overview effect, shift in perception, shift in agency, shift in ability to act. So those are some of the themes we're trying to take on, both in the space and planetary design track and in the post-planetary and universal design tracks that we're working on. Let me introduce our speaker today, Ben Goertzel. As Ben himself says, his main focus right now is the Singularity Net project, which brings AI and blockchain together to create a decentralized open market for AIs. He envisions it as a medium for the creation and emergence of AGI, a way to roll out superior AI as a service to every vertical market, and a way to enable everyone in the world to contribute to and benefit from AI. Ben's work over the past few decades has engaged the challenges, of course, of developing AI, AGI. He's also taken on life extension biology, philosophy of mind, psi, consciousness, complex systems. Also, improvisational music, something that we both share a tremendous love for, experimental fiction, theoretical physics, and metaphysics. Some of the positions of note that Ben holds now include the CEO of Singularity Net since 2017, chairman of OpenCog Foundation since 2008, chairman of the AGI Society since 2010, chief scientist at Mosey Health since 2016, and vice chairman at Humanity Plus since 2011. He's also worked very closely with Hanson Robotics and was chief scientist with them from 2015 to 2019. And that's just a very short list of his many roles over the years. Our respondents today will be some of the members of the New School Policy and Design for Outer Space group, which includes Weston Finfer, Colin McLean, Leo Sousan, Sonia Zhang, Zach Williamson. The objective of the New School Policy and Design for Outer Space group is to propose policy and design incursions related to the investigation and eventual habitation of space, with a commitment to incubating interdisciplinary work that maintains an awareness of or actively seeks to resist the colonialist legacy inherent in contemporary space-related theory and praxis. Their areas of interest and research include space laws, space habitats and their governance, economy, existential risk, communications and information theory, bioastronautics, geocognition, geotrauma, digital earth, deep time, as well as the ontological mysteries that these all entail. So we have a really wonderful set of respondents to join us today. And of course, we have Ben Goertzel. So Ben, without any further ado, I'd like to hand it over to you. Thank you so much for joining us today, Ben.
Well, thanks, Ed. Yeah, this is an honor and a privilege to be speaking and interacting, and it's kind of jamming together at one of your events once again. So, yeah, I mean, Ed and I started going back and forth on all these crazy topics, probably a little bit in 1982, more so in the 83, but like back in the pre-dawn dark ages, when very few people took notions like AGI and singularity too seriously. And I mean, the core concepts we were discussing back then when we knew each other in university, I would say, are quite similar to the concepts that preoccupy both of us now in our own separate ways. I mean, like, what is the mind? What is space? What is time? Like, what the hell is existence? And I was working already then, trying to code AGIs by approaches that seem extremely naive to me in hindsight now. But when I was like 15, 16, 17 years old, I was already possessed by the urge to implement thinking machines. And, you know, we, with our group of college friends, we were already discussing, like, well, what does that really mean? What is thinking? What is consciousness? Like, what would the world look like to this AGI system if we could succeed at building it, right? So I would say some of these issues that we were wrestling with in the 80s actually have been partially resolved to interesting degrees since then. Like, there actually has been progress in understanding some of these things. And then in other critical aspects, I think it's fair to say we're all equally confused as we were back then, or maybe even more confused as we've understood more and more dimensions of the complexity and then confusion of the very deep issues involved. So with the theme of this session on the overview effect, really, one could go in an incredible number of different directions, and could keep going for years without stopping, without plumbing the depths, or without coming to definite conclusions based on our currently uncertain state of knowledge. I think for most of the remarks I'm going to give today, I'm going to sort of grab onto the concept of intelligence and sort of flesh out what is intelligence, how should we conceive intelligence, how will our conception of intelligence change as we advance toward and beyond this a singularity. Not necessarily because intelligence is even the most interesting or relevant concept to take as a starting point, but you got to start with something, and in a way, sometimes no matter where you start, you're going to end up at the same place anyway. There's a lot of entries into this concept space that we're exploring. But before I plunge into intelligence and AGI, I want to comment briefly on what the overview effect simulated in my mind when I first read the title. So I mean, I went on Google and looked up and saw the overview effect is a cognitive shift in awareness reported by astronauts during spaceflight while viewing the Earth from outer space. And of course, you know, first thing that popped to mind, like my first memory literally is watching Neil Armstrong walk on the moon, because I mean, I'm 54 and a half years old. I was like 1.5 or 2 or something at that time. And it was like such a big thing. Everyone was so amazed that it struck in my mind, like this must be important, because all these big people think it's important. And I remember being confused by Neil Armstrong, because he said, like, a small leap for in some way he screwed up the syntax for it. He said, like, a small leap for man, a great leap for mankind. And so, whereas he meant to say a small step for all man, a great leap for mankind. So I was very confused. If it's a small leap for man and a big leap for mankind, what's a mankind? At the time, I thought a mankind was like a miniature man, like a few inches tall. So, and I thought they'd brought some miniature people on board the spaceship who would then had to make a really big leap to get onto the moon. Right? And I think I was 6 or 7 by the time I realized that mankind was just some stupid abstraction instead of like something that was kind of like a man, right? But and anyway, the idea of the Earth as viewed from space was sort of, due to my generation, put into my head at a very early age, and it sort of projected me to get into Star Trek and all sorts of science fiction. And yeah, it's really it's a special case in a way of the shift between a third and first person perspective, which is a shift that we're doing all the time. So like another early childhood thing I can remember is when I first got glasses at age 5, I was all of a sudden like, wow, the world looks completely different when I hold these things in front of my face. And how can the world be so different based on this little physical object? Because my vision was quite bad, but no one noticed it until I went to first grade on the first day, and I couldn't see the chalkboard and stuff, right? So then again, that's, the seeing the Earth from space is a first versus third person thing, and then noticing that everything is totally different with your glasses on or off. I mean, this is just it's noticing that in some sense there is no out of context, right? Like everything is in some way observer dependent. And then much later in life, I started getting to these states of consciousness where, as I walk around the world in everyday life, I see everything from the top down, like the third person view in a video game, instead of seeing in the first person view, which to some degree is a constructed illusion, because from a certain perspective, I cannot really see the back of my head as I'm walking around, unless I'm psychic. So maybe I can, I don't know. But I mean, the sense of seeing everything from top down as you go about your life is quite interesting, and I'm not the only human to ever report that, but it's interesting, and it gives you a different view. Like, it gives you the same view as seeing the Earth from space in a way. It's like you are one ant in the ant colony buzzing around. Like, you can see yourself as a neuron in the global brain going around and doing these things without seeing yourself as like the central agent in the whole theater, right? But of course, you can't lose track of the view of yourself as a central agent in the whole theater either, or you'll like get run over by a truck or something, right? So there's this back and forth between the sort of agent centric first person view, where you're implicitly assuming that the reality you're seeing and interacting with from your own embodied agent point of view is the main thing, and then the broader view, in which you were just like one little blip bouncing around among all these other blips in a complex system. And the integration of these views, which doesn't have to be a logical unification, but can even be a sort of paraconsistent collaboration or something, right? The integration of these views is, it's an important thing for each of us to get right in our own psychology and lives and interaction with the world. But it's also actually an important thing in AI and in understanding what intelligence is and how to build artificial general intelligence that will lead us to a positive singularity and all that. So as I spend the next 20 minutes or so going through some concepts of intelligence, I'm gonna come back to these broader concepts of different perceptions of the world. So I want to talk a bit about a way of thinking about intelligence, which my friend David Weinbaum, aka Weaver, introduced in his PhD thesis, which he's now turning into a book, which is what he calls open-ended intelligence. And this is it's a different way of thinking about intelligent systems, which is rooted in complex systems theory and continental philosophy, and not necessarily contradictory to the more mainstream ways of thinking about intelligence in the AI field, but certainly adding a bunch of aspects that are not commonly being addressed in the AI field, in the field of cognitive science right now. And I think thinking about AI systems as they are now and how they will be in future in terms of open-ended intelligence, it's both important for those of us concerned with building AGI systems now, but it's also important in terms of connecting what's happening and will be happening in the AI field with all the other sorts of intellectual and practical threads that are being pulled together in this overview effect event. So there's intelligence, starting with that concept now, and then weaving back in these broader themes. There's a lot of ways of thinking about intelligence, right? I mean, there's IQ test, which is interesting, and there's something non-trivial there, which is that different sorts of cognitive abilities among humans have a not insanely great, but beyond trivial correlation with each other, right? So like on average, people who are good at math are more likely to be good at science and also more likely to be good at like analyzing foreign policy situations or something. Clearly not 100% correlation, but there are correlations between these different capabilities of doing mental tasks that are relatively difficult for humans. And so the IQ test was designed to try to measure this sort of common core of intellectual capability that seems to make you better than average at a whole bunch of tasks that humans generally find cognitively difficult. And there's some statistical meaning there. It's often exaggerated, but it's also often sort of dissed too hard, because there is something interesting there. Like if I was trying to hire AI programmers, I would do better to hire 50 people with an IQ 150 than 50 people with an IQ of 80. Even though IQ test is culturally biased and flawed in all sorts of ways, there's still something there. There's also something to the notion of multiple intelligences, right? Which is more recently introduced, and which aims to differentiate sort of being good at mathematics from being good at music, from being good at literature and so forth. And you can measure each of these separately. You can also try to measure the common core. It's ironic, after talking about having glasses as a way of getting insight into the world, the lens of my glasses started falling out in the middle of giving to this talk. So this is must be some example of the trickstery nature of the multiverse, right? So that there's these sort of very human centered measures of intelligence, like an IQ test or multiple intelligences, and then there's a whole thread within the theoretical AGI community of more general and mathematical conceptions of intelligence, like Marcus Hutter, who has a theory of universal AI in a book by that title, and his student Shane Legg, whose PhD thesis was universal. I forget honestly the title of Shane's thesis, but the concept was universal intelligence, machine superintelligence. That was the title of his thesis. And then Shane went on. He worked for me for a few years at my old New York AI company, WebMind. He did his PhD on machine superintelligence with Marcus Hutter, who was the inventor of the mathematical universal theory of artificial general intelligence. Then Shane went on to co-found Google DeepMind with Demis Hassabis. But before Shane plunged into Google DeepMind, and after I sort of introduced him to AGI development world, he worked on a PhD thesis trying to mathematically define what is intelligence. And what him and Marcus came up with was sort of the ability to achieve arbitrary reward functions in arbitrary environments, or more precisely, arbitrary computable reward functions in arbitrary computable environments. Now, in my first book, The Structure of Intelligence, in 91, I tried to define intelligence as the ability to achieve complex goals in complex environments, where I define complexity in terms of algorithmic information theory. Shane and Marcus proved a lot more nice theorems about it. It's how to, so you have any world, any environment that can be described by a computer program, even if a very, very big one. And most physicists now believe our physical universe can be described by some computer program, for example. Then you have a reward function, which means that when an intelligent agent carries out an action in the world, it not only gets a reaction in the world, it gets some quantitative reward, which could be 0, could be 10, it could be 3. So they figure the extent to which a system can figure out how to maximize its reward for any computable environment, given any reward function, giving it rewards based on its action, that's its intelligence. So then they define general intelligence as the average over, basically the average over all computable environments and all computable reward functions of how well can that agent optimize those reward functions over those environments. And there's a lot of funky math related to how do you take that average. You get into the Solomonoff universal measure over program spaces and so forth. But there's a couple observations to make about this way of thinking about intelligence. I mean, one is, according to that sort of measure, humans are really, 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 really stupid, right? Like we're very bad at optimizing arbitrary computable reward functions over arbitrary environments. We can't. I mean, most people can't even multiply large numbers, but I mean, none of us, however clever we are, can efficiently run a maze in 773 dimensions or something, right? I mean, we're very specialized to this 3 dimensions of space, 1 dimension of time world, right? So I mean, we're not that general. We're interestingly general in that we can understand what a 750 dimensional maze is, and we could write software to run it, or some small percentage of humans can, and we could build computers to run that software. But on the whole, all biological organisms and the whole human global brain and the whole ecosystem of Earth are pretty dumb by this theoretical measure, right? In fact, the entire physical universe, if it were shaped into the optimal AGI device by rearranging all the quarks and gluons, would still be dumb according to this measure, right? So this is like in some ways, too big and too strict of a criterion. But it's interesting to understand, how big the ambition of an intelligence could in principle be. The other thing you see when you think about this in detail is actually, how important and central is optimizing reward functions, right? I mean, that's game playing in a way. It's kind of cool, but I mean, the difference between learning and development in developmental psychology is, I mean, learning, you're given a certain task and a certain body of knowledge, and you're trying to get better and better at doing that thing, right? And development is more about fundamentally restructuring and modifying yourself and becoming a different type of system. And one thing that happens in development in human beings as we develop over our lives, I mean, one thing that happens is the reward functions that we give a shit about change, right? And the goals that we have change, and we may not like that, but it happens. Like most of us probably as a little kid had the feeling like, well, when I grow up, I'm not going to care about all that stupid shit that these old adults care about, right? But then suddenly you grow up and you do care about all those things that adults cared about. Maybe not exactly the same way as the adults you were looking at as a kid. Maybe you retain more childlike, playful spirit than the adults you were irritated at as a kid. But still, your goals change. The reward functions you care about change through self-modification, some of which in this case is genetically triggered, and some of which is just self-organizing complex processes that would be extremely challenging to predict. So you could see that on the one hand, the IQ test and sort of Gardner's multiple intelligences approach is too human-centric, right? Because if you're building AGI systems, I mean, the AGI systems may not care about music, but they may invent whole new media that we can't understand. And verbal intelligence may be as interesting to them as like barking intelligence among dogs is to us, right? So, so, these human-like ways of measuring intelligence may have interesting social or cultural or practical functions. They're not much good when you're thinking fundamentally about what intelligence is, nor when you're thinking about building superhuman AGI systems or something, right? Well, on the other hand, these mathematical, like algorithmic information theory, computer science definitions of intelligence, they're almost too big and not taking into account like practical, physical, or energetic or cognitive constraints of real worlds. And they're also fixated on like getting high score in some notional video game of reward maximization, which is not even the most interesting sort of video game, right? So then what Weaver is after with open-ended intelligence is coming up with ways of thinking about intelligence that apply to complex self-organizing systems as they develop and self-modify and grow and move into domains that they or their creators never conceived, which may involve making up new goals and new reward functions or new ways of self-motivating that don't involve anything as crude as a one-dimensional reward function, right? So how do you take super intelligence that may have gone beyond the human level, but yet without necessarily becoming infinite? And how do you come up with a way of intelligence that lets you think about that, human beings, ecosystems, bacteria, bacterial colonies, global brains, and think about intelligence in this really general way, yet still a practical way? I mean, that, of course, that's hard, and neither Weaver nor I has fully solved that problem. But I think the notion of open-ended intelligence is worthwhile, and it is guiding some of my practical work. And I think you can look at this from a philosophical or practical view. So from a philosophical view, you can see the mainstream of AI today, which really is based on notions of reward maximization, similar to Shane and Marcus's theoretical notion of AI. I mean, the whole paradigm of AI that's focused on getting the best accuracy on a face recognition training data set, or getting the highest reward function for a robot in factory robotics or something. I mean, this whole paradigm is based on a philosophy of mind and a philosophy of life, which says that like systematic pursuit of precisely defined metrics is the thing. Like the goal and the means of achieving that goal should be separated. The world and its reward function are distinct from the mind. Time exists as an objective thing independently of the mind, as well as reward existing as an objective signal independently of the mind. So for open-ended intelligence, if you want to come up with a different way of conceiving intelligence, you want to start with a whole different philosophical framework, right? So you want to, I mean, you can start with postmodern philosophy. You can start with complex self-organizing systems theory. You could start from various different directions that make a lot fewer and different sorts of assumptions, right? So I mean, in my own dim prehistory, I was heavily motivated by Friedrich Nietzsche and Charles Peirce as philosophers. And it's not the best known aspects of Nietzsche's thought, but if you look in, say, book 3 of The Will to Power or in The Twilight of the Idols, a bunch of his later writings, I mean, Nietzsche was really looking at how does the mind construct the world, and what is a mind that the mind can construct the world and reconstruct itself, right? I mean, Nietzsche said that there is nothing but morphology and will to power, right? And morphology is form, structure. So he's viewing the world as forms and structures that are trying to impose themselves on the other forms and structures around them, and in doing so are growing and transforming themselves. And Charles Peirce, who invented quantifier logic and a whole bunch of other cool math, and gave William James most of his original ideas, or many of them anyway. I mean, Peirce also, he viewed the tendency to take habits as the primary driver of mind. So he's looking at patterns patterns that tend to extend themselves more than assumptions of probabilistic independence would lead you to think they could. So again, you have a view of the mind as a self-organizing pattern system with emergent patterns popping out of it, right? And then Spencer Brown, with his laws of form paradigm, was going in a similar direction. And then a bunch of the French postmodernist philosophers. I mean, I was deeply into Baudrillard and Foucault, but there's a Deleuze and so forth. I mean, in the end, these guys are looking at things the same way. I mean, I probably reread Difference in Repetition like 10 times before I understood what the hell it was talking about. But I mean, in the end, that's really going in the same direction. I mean, Spencer Brown, if you look in his laws of form, he takes distinction as the primary concept. So, because any concept is making a distinction between things that fall under that concept a lot and things that don't or fall into it a little. So, in a sense, distinction is the most primary proto-concept underlying all other concepts, because every concept makes a distinction. And Spencer Brown shows how you can build up all other concepts by recursively nesting and combining distinctions. I'm getting an interrupt by my 3-year-old kid. Give me 1 second. I'll be right back.
I don't want to go quite fast.
The other car that goes very fast? I do not know where the other car that goes very fast is. You think it's in here? You mean the white one that Svetoslav gave you?
Yeah.
I don't know. Where's your mom? Is she busy?
Yeah. I saw he making us. You hear him? You hear him?
That's turned off. I'll be back. That is turned off now. But I have to work. I have to keep talking to these people. You can ding, 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 ding. When I'm done talking to these people, I'll come play with you. I don't know where that other car is. All right. We got some hot race car action here. I'll look for that car when I'm done working, okay? Or maybe your mom will find it first. All right, where were we? We were postmodern philosophy, right? Yeah.
And Spencer Brown, recursively building
Yeah.
up all
So
concepts.
if you look in Deleuze, difference in repetition. I mean, you have there. I mean, distinction, as Spencer Brown articulated it, is closely related to difference, as Deleuze conceives of it. It's certainly one way of thinking about it, and how you get from distinctions to repetition is really, really interesting, right? Because to repeat something, you have to go beyond difference to sameness, right? To repeat something, you have to identify it is the same thing. But what does it mean to say it's the same thing? It's actually never the same thing, right? And so what Nietzsche said is that the coarser mind sees more things as equal, right? So like if you're the mind of the whole universe, you're seeing everything, like then there is no repetition, because every moment you can never step into the same river even once, right? I mean, nothing is ever exactly the same. On the other hand, if either out of choice or habit, or just for kicks, you adopt a coarser perspective, right? Which we all do as humans. I mean, then I am seeing this coffee cup, and this coffee cup, and this coffee cup, right? I'm seeing those as the same coffee cup. They're not actually. There's a lot of flow through of elementary particles there, right? And so they're not really the same coffee cup, but I'm assuming they're the same coffee cup. And so the repetition has a couple aspects. I mean, one is timeline. So you're assuming there's some emergent assumed timeline over which repetition is occurring, and then there's clustering of some form, like assuming that that these unique instances are belonging to the same category, right? And once you do that, then actually once you get to repetition, you're a long way toward constructing an intelligent mind, because you're having to cluster unique things into concepts, and you're also then having to arrange these concepts in some temporal series, which is a large cognitive act. And if you look at a newborn baby, they're not good at any of those things, right? Like they're more so like each thing is like a wild new thing that they've never seen before, and they don't necessarily sequence things into an order. It's more of a sort of spherical or amoebic model of time or something, right? So we settle on these cognitive constructs that let us build the notion of repetition, sort of in my 4-month-old daughter already has it, but she didn't when she was 4 days old, right? So we get these things at a very early age, and then those are in some ways, those are the hard part, right? I mean, those are the hardest part in building up a mind. Although dogs and cats and frogs are already have them. I mean, there's a lot of other steps to get up to human level intelligence. But yeah, I would. So I've gone through these ideas in a somewhat different way in a paper I want to point out, but I'm not going to have time to go over in detail now. So I introduced an awkward neologism called Uri physics, EURY physics, and the concept of the Uricosm, EURY cosm, where Euro or Uri is a prefix meaning wide, which is why Europe is like the wide land. And what I'm talking about there is the notion of a wider universe in which our universe, our physical universe, is a small subset. And I'm trying to ask what could be the structure and dynamics of this wider universe outside of our physical universe, right? And that ties in with issues in theoretical physics, where you can look at what is the wider universe that can in which general relativity, quantum theory, and maybe further forms of physics can all coexist and not be contradictory. It's an interesting tool for exploring issues in parapsychology or reincarnation, survival after death, if you're into this weird stuff. And I've written a bunch on the empirical data that these phenomena in some form exist. But it's also interesting for thinking about consciousness and what is consciousness, which is something that comes up in the AI field a lot, because my own view of that is somewhat panpsychist. Like, consciousness is immanent in everything, and there's a consciousness aspect to everything, but that doesn't mean consciousness aspect of everything is equivalent, right? I mean, the consciousness of a human and a bug and a cup are different, and it may be interesting to think about a sort of wider universe as one that contains aspects of our consciousness that are not bound to the physical. I mean, I think that the whole dualist idea of consciousness, that consciousness is something separate from the physical world, got a bad rap because it was tied in with sort of what I view as conceptually primitive religious aspects, which have some interesting truth to them. But I mean, you can, just like string theory gives you 26 or 11 dimensional containing macro universes in which our 4-dimensional universe can coexist. I mean, you can think about broader containing universes that have aspects of mind and consciousness, and it doesn't have to be religious or voodoo. It's just accepting that our 4-dimensional space-time continuum that our science happens to have discovered now may not be the be-all and end-all. Just like the flat 4-dimensional world that people thought existed before Einstein wasn't the be-all or end-all, right? So all these philosophical notions point you to a view of intelligence which is a little different than optimizing reward functions. And Weaver really hammers on the notion of individuation, which is is something that comes out of Deleuze and Simenon and other postmodern philosophers, but also ties closely into complex systems theory, notions of self-organization, and then autopoiesis, which means self-poetry, but self-building, like a system reconstructing and rebuilding itself, which all biological organisms do, and also all minds do, as I wrote a lot about in a book I wrote in the mid-90s called Chaotic Logic, where I was writing about connection of autopoiesis and AI for the first time. So individuation is really, that's the notion of a complex self-organizing system reconstructing itself as an individual, right? As a system. So it's a system constructing itself and thus implicitly on some level conceiving itself as a system. And this ties in with repetition from Deleuze quite deeply, in that to repeat, you have to have some object which is repetitive, like the object is there at multiple times and places, even though the details underlying it can't be the same because it is at different times and places, right? So individuation is a little broader than that, but it's a matter of a system reconstructing itself as an individual, which is then interacting with an environment and other individuals. And when you look at it from a complex systems view, an individual is then it's a sub-network of a broader network, but it's a sub-network which is restructuring itself as a network in such a way that it will be able to continue a while as an individual, right? And this process of individuation gives a different way of thinking about intelligence, because another way of thinking about intelligence I should have mentioned before. So Pei Wang, who's another AI theorist I've worked with for years, he has his own AI system called NARS, non-axiomatic reasoning system, which is a little different than my own AGI approaches that I'm going to talk about for like 1 or 2 minutes, because I want to go to discussion soon. But Pei Wang defines intelligence just as the ability to adapt in an uncertain environment, right? And I mean, he's from mainland China. I always thought that's a very Chinese way to look at it. Like, we Westerners want to look at optimizing reward functions, and the Chinese guy wants to look at adapting to an uncertain environment, right? And that's I think, of course, I don't want to be culturally reductive, but clearly there's something in Chinese philosophy that pushes you in that direction. Like Chinese government has in some form or another persisted for 5,000 years. Like, it has been very good at adapting to an uncertain environment. Individuation is much along those lines, right? So it's about adapting and persisting as an individual as many things change. And there's then the notion of transduction that Weaver introduces, and transductive chains, which is like, how does the individual conceive itself and then transmogrify and modify itself into a different individual, where there's still a continuous chain between those two individuals, right? And this is not intrinsic to repetition, because you could have repetition in like a random series of events identified by some mind that's just recognizing the same pattern over and over. But repetition in our actual physical and cognitive world often has to do with transductive chains. It often has to do with processes that are engineering their own repetition by building a bridge between themselves and something later that has some differences and some similarities, right? So that if you look at an intelligent system as one which is individuating itself in the face of a complex, uncertain environment, and is growing itself during this individuation via transductive chains, where one individual turns into the next version of the individual, turns into the next version of the individual. I mean, this is a different way of thinking about general intelligence, which closely ties into the development that we do over the course of our lives, and sort of ties into the way that an AGI system is going to be rethinking and revising itself. And you could see that if the environment is complex and uncertain, then to ongoingly individuate yourself through constructing a transductive chain along a timeline through your sequence of individuated forms. I mean, this will no doubt require you to optimize a series of complex reward functions in complex environments, right? So the goal, achievement, and reward optimization part is there, but it's not put there as the end goal, right? And just as anticipation and prediction are there, but they're not necessarily the end goal and the be all end all of it, right? So to wrap all this up, I want to briefly mention the two big AGI oriented projects I'm working on now and how they tie in with all these philosophical conceptions. So I'm working on a lot of different projects now, many of which are involved with applying AI tools in different particular domains. Like we have Singularity DAO, which is applying AI to decentralized finance and cryptocurrencies. We have Rejuve, which is applying AI to longevity biology and understanding what makes people get old and die. So we're working on AI applied in sustainability and supply chain, a whole bunch of different things. But in terms of fundamentally trying to work toward greater and greater intelligence and ultimately superhuman intelligence, there's two things I'm working on. One is a new version of the OpenCog AGI system called OpenCog Hyperon. Another is a Singularity Net decentralized AI platform. And I'm sort of thinking these two are going to need to work together to get us toward emergence of AGI in a really good way. So what Singularity Net is, it's a decentralized platform that lets multiple AI agents, whoever created them and wherever they may live, it lets these different AI agents communicate with each other, cooperate, collaborate with each other, self-organize into assemblages that can then outsource work to other assemblages. And then in the practical sense, this network of AI agents can then carry out tasks via various APIs which are requested from other websites or software systems. So I mean, from a user point of view, you're looking at some company or someone who built a website or some app needs AI services. They're placing a request. Can anyone classify these images? Can anyone answer these questions? Can anyone, synthesize an artwork according to these specs or prove this theorem? Some AI and Singularity Net network will say, okay, I can do that with this amount of accuracy and quality for this amount of money and this amount of time. Then they can make a deal, and you get AI software as a service from this decentralized network. On the back end, what's happening is the various AI agents that are providing practical services in the Singularity Net network, they not only interact with customers who are requesting tasks done, they interact with each other. So they can share knowledge with each other. They can form groups to help answer some requests. They can outsource work to each other. And so you have a self-organizing AI network, which is trying to get reward in the sense that it's trying to provide valuable services to customers in the outside world. But what those customers want is going to be changing over time in very complex ways, and indeed may depend on what the AI network is doing and offering, right? So the reward function is being shaped by the system's own activities in a deep way. Now this approach to AGI is it's not fixated on any one AI algorithm or paradigm, really. It's really building a self-organizing network. And we're working on sort of what is the language that different AIs in the network use to communicate to each other their various properties and requirements and so forth. Now, OpenCog Hyperon is a different thing. It's a little closer to the more traditional computer science approaches to AI. So in OpenCog Hyperon, you have a knowledge hypergraph, and then you have multiple AI algorithms that cooperate in reading from and then updating this collective knowledge hypergraph. So you have a probabilistic reasoning algorithm, a variety of deep and shallow neural networks. You have an evolutionary learning algorithm that tries to learn new sub-programs represented within the network, right? And these are all cooperating together in shaping the same knowledge graph, some subgraphs of which encode programs that can carry out actions in the world. And the difference between that and Singularity Net is in Singularity Net, the different agents in the collective don't have to have any shared representation. I mean, they're more like people in this society. They have a shared language. Whereas in OpenCog, there's a shared memory. There's a shared knowledge hypergraph, metagraph representation for the different AIs, and that's more restrictive in a way, but it also can lead to deeper collaboration, right? I mean, so you can think about sort of the difference between a group of programmers all working on the same project where they have this shared code repository and shared specifications, shared whiteboard. And that's like the different AI agents operating within an OpenCog Hyperon system versus, say, different software companies that are building software to operate in the same ecosystem and interact with each other. But they don't have to all see each other's GitHubs, and they don't have to understand all each other's ideas that well. They just have to know how each other's software works. And that's more like the different agents interacting in Singularity Net. So I think having these two levels there, where you have a fairly powerful AGI framework like Hyperon, but interacting within this broader, more diffuse network, which may have it may have Pei Wang's NARS system in there, it may have DeepMind's deep reinforcement systems. I may have many different AGI approaches interacting within this broader network, along with narrow AIs and less intelligent software systems, right? So I think this sort of system is a way that you could brew an open-ended intelligence on the internet today, right? And there's an interesting balancing act there in many different ways. So I mean, one of them is we're not entirely counting on AGI just to crystallize and pop out of the decentralized network, but we're also not trying to micromanage and engineer every little bit of what the AGI does, either by giving expert rules or by curating exact training data or by giving one strict reward function to rule them all or something, right? So we're engineering knowledge representations and learning algorithms, but we're then throwing them into a decentralized pool so they can adapt to that, where the highest level intelligence is going to be in this whole decentralized network, right? And this finally gets back to the top-down versus first person view, right? So I think a suitably open-ended conception of general intelligence has to let you think about and design and study general intelligences from first, second, and third person views at least, right? So the view of what is the individual intelligent agent, the view of like, how does this agent fit into the whole swarming mess of life on Earth and beyond into the Eurocosm, right? And then second person, which is how is that agent synergizing with other intelligent agents? Is it having rich like I-thou relationships with other intelligent agents, or is it only objectivizing them? And you need to think about intelligence in a suitably open-ended way to take a first, second, and third person view of the intelligences that you're building. And if you can do that, then interacting with those intelligences, it may also have a consciousness expanding effect on the human beings interacting with the intelligences. Because if we look at what humanity needs to do in the next few decades, we need to make sure the development of AGI, which is almost inevitable by now, is going to go in a beneficial way, which is good for humanity. But this has as much to do with the software that we build as with the states of consciousness of the human beings building the software. Like if all the human beings building the software are just concerned about making as much money as possible for themselves and their companies, or letting their nation or tribal group defeat all the other nations or tribal groups, probably we're going to get a very perverse-minded AGI system that will not be beneficial for itself or for humanity. Whereas if you have an open-ended AGI network that is carrying out beneficial acts in conjunction with human beings who are using the software fueled by it, and they're helping to build the software, right? And then you may have a situation where human beings are moving toward more and more open-ended intelligence themselves, rather than constrained forms of human intelligence. And then human and AGI intelligence are co-evolving in the network of what some of us have called the the global brain, right? And so you can view all these intelligent networks we're building, as well as the growing intelligence of humans, and in many ways the ecosystem of plants and animals, and the ecosystem even of buildings and cars and machines. This is all part of one global self-organizing system. It's all one open-ended intelligence, and the systems that we're engineering are part of that, right? And we need to be viewing that in an overview way and in an organism-centered way, and we need to be integrating all these perspectives in a way that is, supporting our own individuation, but also our own construction of transductive chains leading from our current individual form to the next individual form. And there's there's a lot more that can be said along these lines, but I think I'm gonna drop off this hopefully amusing ramble now and move into some discussion.
Ben, thanks so much. I kind of had myself muted so I wouldn't interrupt the main video feed, but I was humming and hawing through your whole talk. I'm Weston, Leo, everyone from New School Policy Design. Let me make one quick response here first, and then just bring up a couple of ideas that were percolating. And this, in part, goes back to conversations Ben and I have had in the past over the years. But Ben, it's funny. I remember after one of the events we did maybe 6 or 7 years ago, we were talking in the dinner afterwards about Deleuze, and I think it was Difference in Repetition. I think Carla was there, and I think she's read it more closely than I have, to be perfectly honest. And I laughed because you were talking to me about it as if I could grasp it, Deleuze's work, at the same level that you can, and I certainly can't. But the one work of Deleuze's that I have some reasonable grasp of, to be just objectively, brutally clear about my grasp, is his cinema books. And there are a couple of key ideas that I end up pulling out of the cinema books because of his reference to Charles Peirce, and the way that Deleuze effectively leverages the history of cinema as a series of case studies to prove the evolution of the movement image transitioning to a time image, and then something even beyond that, which would be like a sound image. And Deleuze makes a kind of rough equivalence between firstness, secondness, and thirdness, pulling out of Peirce, ultimately saying that, as you know, but for everyone else in the chat who might not know, firstness, loosely described, could be something like a cow sees grass and is hungry, so it eats the grass. Secondness could be loosely described as something along the lines of the cow somehow thinks about itself being hungry or wanting to eat the grass or how the grass tastes. And thirdness would be something where you transition from a metacognitive state of perceiving yourself perceiving and building models about perceiving oneself perceiving to, for my mind, the most interesting moment in Deleuze's cinema books, a moment where a kind of a dream memory or an error, or in the Michel Serrian sense, a parasite-like relationship emerges where there's noise in the transmission. There's an included third, which produces an unexpected result. Now, the other reason I'm bringing this up is it relates to point of view. And the question then becomes this kind of instrumental question for Deleuze, and he refers to Vertov, for example. Vertov building a cinematic theory of montage, which would allow, as he puts it, any point in space and time to connect to any other point in space and time whatsoever. So it's funny, if you look back at the revolutionary project of a filmmaker like Agi Vertov, you might say initially, oh, well, this is part of a kind of a Soviet project, which is looking at ways of building an equal platform for all humans on Earth, or equalizing the production of culture and the production of material goods and the production of labor within a kind of a post-scarcity battalion general economy. But in fact, the kind of even more revolutionary project that Deleuze is attributing to Vertov would be this kind of universalist construction of any point connecting to any other point whatsoever. So the point of view could be shared. This is a really, really, for me, like, fantastic set of implications in Deleuze's project. And of course, you would say, well, of course, this would be Deleuze's project because he's a philosopher who's interested in constructing, as As you know, other philosophers who have critiqued Deleuze might have said a kind of a universalist and royal and monovocal philosophy of the totality of the universe. Badiou, in his book on Deleuze, makes an argument kind of like that. But for me, that's the strength in Deleuze, because it's an attempt to think through the instrumentality of cinema as a set of case studies which show the evolution of an increasingly self-perceiving and sapient system, constructed by humans, but in a way very similar to, Ben, the way that you've been describing this, emerging out of a set of phase spaces of potential sapience. So humans are not the author per se of this, they're the facilitator of this. And so the other point that I would want to make here, Ben, is to link that observation. Let me just be super clear for everybody. So the point I'm bringing up there is, what are the instrumentalities that lead to a specific form of mind? And Ben, you made a comment about this. I think it was at the Transhumanism Meets Design event 10 years ago, being interested in what types of mind emerge out of what kinds of world, or what kinds of world are necessary to produce specific kinds of mind. So it's a question of instrumentality. So then it becomes like a specific set of design tasks that we have to engage. We have to design a taxonomy of worlds, or a taxonomy of ontologies, to then predetermine a taxonomy of mind types, or ontologies of mind. So that's one first point that I would make here. The second point goes to a question of self-interpreting code. And I want to bring up communication with ET, intelligence, SETI, going back through, of course, Sagan, but looking also at Chomsky and Ollengren. Now, I've been reading and rereading Oberhaus's book on extraterrestrial languages recently, and I mentioned this briefly in yesterday's lecture as well. Oberhaus makes an interesting point drawing on Chomsky, if I recall correctly. The hypothesis being that language is not so much a communication tool as a thinking tool. Maybe it's even more a thinking tool than a communication tool. So any external or exogenous system, an extended phenotype, if you will, would potentially occupy the space between a thinking tool and a communications tool. So architecture, technology, music, clothing, cities, infrastructure, gestures. And Ben, you met Gary Tomlinson a few years ago at one of the events that we held at the New School. Tomlinson's work on the soundscape and the taskscape, which he talks about in his book, A Million Years of Music, is resonant here for me, no pun intended. He makes the argument that human cognition formed across literally 1 million years of interactions, pre-human cognitive interactions, quasi-modern human cognitive interactions across countless generations, as these pre-humans interacted with the taskscapes of their world of survival and the neuromuscular sensate mind ensembles across thousands and thousands of generations formed a set of habits through their interactions with that soundscape, taskscape, which then facilitated to some extent the kind of modern cognitive structure that we have right now. And so this ties to types of world for me. And I wonder then, what type of world do we want to design, or what observations do we want to make about the world that we inhabit right now to facilitate a specific kind of mind, or a specific set of species and subspecies of mind? Maybe I'll leave it there, because I wanted to make a jump to Wolfram as well, but then it's going to get very, very messy. So this is just a set of prompts around world type. What minds emerge from what worlds, or what worlds do we need to design to facilitate specific kinds of mind? And the technical instrumentation there. And it's a kind of a lead into what you were talking about also in relationship to OpenCog and Singularity Net, because I know that you've been thinking about that and the different technical aspects, for example, of blockchain, and which kinds of blockchain might lead to which kinds of mind.
I also, in a broader sense, I thought a lot about what kinds of worlds might different kinds of minds that we build open up to us, right? Like there's a science. I mean, the universe is quite rich with many things in it that we just may not notice. Like I think about how, when my dog runs past me talking to the computer, he thinks I'm sitting wiggling my fingers. He has no idea what the internet is, or that I'm talking to these people in New York City or something, right? So, I mean, entirely possible once you get an AGI a few times more generally intelligent than humans. It notices the ambient alien life forms all around us with massively superhuman intelligence, and then the world appears totally different than anything we conceive now, right? Or, I mean, relatedly, perhaps the same, perhaps differently, like an AI with sensors at the quantum level, right? Then that can directly perceive and interact at that level. I mean, then what worlds is that AI opening to us? They're not worlds that are directly in the structure of that AI. They're worlds that the AI is configured to elicit from the broader universe, right? And I mean, and that's sort of like our physics class elicit the atom bomb from the potential where that was there all the time, right? It was in these little atoms inside us. We had just had to get the knowledge we just had to find the knowledge to get it out. So there's like, what worlds do we want to design? But then there's what probes do we want to design to poke the broader incomprehensible universe, to reveal unknown worlds that are like hiding in plain sight, right? And that's not the kind of thing we are well attuned to think about, really. I mean, it's we don't even have the right language to describe the process. So it's a sort of thing we fall into quite haphazardly.
It's a really interesting point on the language that needs to be designed or built out for this kind of thing, because as I'm listening to you describe these various AI projects, I mean, it sounds much like a ecosystemic approach, but is that a way that you want to think of it as we're moving into this more artificially generated series of connections, different scales, all these essentially moving parts, these agents, like just from that very basic bit of language, like, is this an ecosystem of AI that you think is built out right now?
Well, so I'm sort of trying to have it both ways, right? Because I think you could create an ecosystem in which AGI will emerge and evolve without too much forcing of it, right? On the other hand, there's unfortunately an arms race aspect to it also, where evolution is slow and resource intensive. And then if folks are just building AGI systems to serve their corporate goals, they might get there faster than your digital prebiotic soup is evolving, and then perform regulatory capture and outlaw your prebiotic soup, right? So with Hyperon project, we are engineering an AGI mind according to a specific cognitive architecture. On the other hand, we want to use that to specifically seed and guide the emergence of intelligence in the whole ecosystem. So I do think a beneficial AGI almost certainly has to come out of a rich ecosystem that involves very diverse groups of people and very diverse software systems sort of interoperating. On the other hand, I want to nudge and accelerate the emergence of the general intelligence there by planting some key components. So you could look at the human brain as a rough analogy in that, the human brain is a self-organizing autopoietic network, and the brain is building itself during fetal and postnatal epigenesis and so forth. But then, as well, there is a particular architecture there, right? Like the neocortex is doing certain things, the cerebellum is doing certain things. So even in the brain, there's this balance between self-organization and the specific architecture. And an organization like Singularity Net, or a company or a country, is even more so. And we've wrestled with that in terms of our internal structure of Singularity Net as it grows. Like, we want to be a loose, decentralized, self-organized organization where every team member can be self-directed and chaotic and creative, but we also want to have some level of organization. So we're working toward building our decentralized AGI platform effectively, rather than just being like a pure brainstorming network or something. So in situations that are more resource constrained in terms of energy and time than the ecosystem on the earth, right? So you somehow want to balance this ecosystemic freedom and self-organization with some level of structure and guidance to accelerate evolution of certain things. And that this is sort of a black art at the moment, right? I mean, we don't have a general science of network organization dynamics to use to help with this. I wish we did, actually, but I guess the general science will come out of the sort of practices that are happening now.
Right, and I think that would be my next question. Just from Lydia's talk yesterday was all on closed worlds and a lot of conversations around scale and resolution and how are we, if we're viewing worlds as closed or trying to construct closed worlds, where do you find those like pinch points or access points? Like what scale is appropriate? Is it the third person, 3,000 feet or higher? How do you get kind of into that closed world? But this is not a closed world, this AGI system. It's very much open, but there are aspects of it that must be closed, I assume. So like you were mentioning this a lot of Deleuze's work, I put in the chat, Recursivity and Contingency by Yokoi. It's basically this kind of same conversation of like, yes, it's continually recurring to form some semblance of self, but there has to be this kind of input or some contingent aspect that is able to allow the system to grow and not just stagnate like much of the closed worlds we were learning about yesterday. So I guess maybe I was just wondering, like, do you think of this like as a cybernetic project or in those kinds of terms? Like you mentioned,
certainly a cybernetic project. I think that, I mean, open versus closed also depends on your perspective, right? Because the whole physical universe may or may not be conceivable as a closed system, but it's a very big closed system relative to us. So then we may as well consider it as an open system, right? So like a closed system that's sufficiently bigger than the given observer is not distinguishable from an open system. And so that then, if we're looking relative to ourselves as human beings with all of our limitations, right? It's pretty clear that if we're building AGI systems that look like they're operating in a closed world relative to us, which is what most AI systems so far are doing, like these sorts of systems may be easy for us to control, relatively speaking, but they're not going to do things that are radical and revolutionary in general intelligence relative to the scope of human history, right? Like, so you say you have a system for proving other math theorems, which my oldest son is doing his PhD on machine learning applied to automated theorem proving in Prague. So I mean, we can feed the corpus of all math theorems that have been formally encoded to a machine learning system, and we give it to it as training data. Then we ask the system to come up with new math theorems, and that's very cool, right? And I personally believe within the next 10, 20 years, math will be solved at beyond the human level, right? Just like so a theorem prover will be like a calculator. You can come up with a new theorem, the theorem prover will crunch and do it, and then the tricks that humans have used to prove theorems will look weird and wonky, just like the tricks we used to do mental arithmetic quickly look weird and wonky now compared to just letting a calculator do the arithmetic, right? On the other hand, you can look at very fundamental, almost existential innovations in the history of math. Like we had informal math until the late 1800s. And then we got formal logic and the whole idea of formalizing math down to like the bit level or the quantifier level. So an AI system that is trained to be a theorem prover on the huge corpus of theorems, it will never make the next invention on the level of inventing formal logic, right? That was development, not learning, right? Like that was a fundamental transformation in like what is the enterprise of mathematics. So if you want AI to make a fundamental innovation on that level, right? So that then the AI needs to be an open system relative to the scale of human beings, right? And that will be very, very scary to many people because it fundamentally is not determinate, right? You're not going to get a guarantee that a system which is fundamentally self-transformative and has the capability to go beyond all human culture, you're not going to have a guarantee that that system will not do anything that is considered bad by a certain particular set of human cultural norms associated with one culture, right? I mean, that's hopeless. On the other hand, that's the only way to get something that's fundamentally radically innovative. And then you get to the question of should we make a system that has this this sort of radical creativity and developmental capability, and the question of like what is the fate of the human race if we do or don't, right? Because there's a lot of other dangerous things going on that are less interesting too.
A question I have related to the idea of like designing a world and closed world versus open world is how the idea of material embodiment configure in your AGI like vision. So I first knew about your work through the through Hansen Robotics and the robot Sophia, where it seems like there's like a crystallization of AI development in a very specific physical representation, whereas the talk, like the examples you bring up in the talk just now, there seems to be like there's a more openness towards whether there is or is not a shared representation, and it might be analog, it might be digital, it might be whatsoever. So I was wondering, what is the relationship between AI software and hardware in your current?
I think, I mean, of course, all AI systems that we're building at the moment are embodied in some form, right? Because the laptop is a body, right? But a human-like embodiment, like a Sophia or Grace robot, is a different thing. And I think that there are some aspects of human culture and human values and human psychology that are going to be best absorbed by an AGI system if that AGI system has a human-like embodiment. Like people bond with robots like Sophia or Grace, which is our new robot. People bond with them and share with them emotionally in a way that's different than they do with a chatbot or with a system that doesn't have that human-like embodiment, and that can be really valuable for the AI to get an intuitive sense of human values. I don't think it's necessary for intelligence in an IQ sense, let alone in like a Marcus Hutter's Shane Leg optimized computer reward function sense, right? Like for an AI to become super intelligent, grokking the details of human values and human emotion and human culture is necessary only to a limited sense. It's necessary for the AI to be able to read the whole internet, but it doesn't necessarily need to empathize with people to be generally intelligent. On the other hand, if we want an AI that will be kind to humans in the way that humans want it to, and that really empathizes with human beings, then fully like soul syncing with humans becomes very important. And I think that the human-like interface is important for that, right? So that's like again, you come back to the high level versus the first person view, right? From the high level view of the evolution of intelligence on this planet, humans don't matter too much any more than dinosaurs did, right? Like we are one species that came about and in some form may go away. And if there's other vastly more intelligent things that come about, intelligence as a whole is emerging, just like we emerge out of the mammals and emerge out of reptiles and emerge out of the prebiotic soup and so on. But if we take the first person view of the human species, right, then we care a lot about the sort of continuity in the transductive chain that goes from the individual of humanity now to the individual of humanity next time, right? So if you're looking from that first person view from the human species, then these robots like Sophia are probably really critical because they're one of the best tools we have for building a close bond between humans and AIs. I mean, brain-computer interfacing will be another really interesting tool that could be even more powerful. We just don't know when that's going to mature to the level that you can suck the deep nuances out of human minds and cultures into an AI, like through direct carbon nanotubes drilled through little holes in the brain or something.
You know, Sonia, thanks for bringing that up, because Weston put in the chat just a few minutes ago Carl Schroeder's concept of thalience, which he talks about both in his novel Ventus and also writes about more from a kind of a scientist's perspective or a theorist perspective. And thalience he offers as what he calls a successor to science. He suggests, for example, that we could build little Carl Sims-like robots that have the capability of exploring an environment like the moon, and we could just send a few billion of them to the moon and let them play on the moon. And each of these robots would develop its own view of what the moon is, an embodied view, but certainly different from your body or my body or Sophia the robot's body. And then presumably they would report back, as he puts it, on what they found. And a few billion of these little Carl Sims-like robots flopping around on the surface of the moon would discover certain parameters of how the moon is, and they would build their own individual and then collective ontology about what the universe is, what the laws of physics are, what materials are, what it means to sense, what it means to flop around on the moon, what the moon is. And that would be a shared and Anya kind of contingent mind, right? So Schroeder is basically suggesting that we have our anthropocentric points of view in relationship to what body is and what the world is. These little robots would build their own robot-centric points of view, and shared between them and us, there would be a kind of a co-produced thalience, which would be a knowledge of the world. Now, to my mind, the funny thing is, of course, and Ben, this is to you know, speak to the point that you made about the kind of ladder of connections from the prebiotic soup to where we are right now. We already exist in a kind of a thalient world, in the sense that there are many, many entities. We share certain aspects of our world together, and we superimpose but don't communicate or even exchange energy at other scales or other interface points. And so there already is a kind of a model of thalience, I think, to the world that we live in and the universe that we live in, at least that we can observe, which I find to be a compelling model. And so I guess to go back to the idea of a system which self-recognizes, Ben, that has the ability in the Spencer Brown sense of creating a distinction, and maybe the initial distinction wouldn't be a distinction, it would be a distinction wherein it can distinguish itself from some other system. Maybe the other system is the world, or the other system would be you or I, West and you and I, or Sonia, you and Ben. That distinction and that act of distinction would be a kind of a fundamental cut to produce world, or to produce sentience leading to sapience, pure perception and ability to process energy and information, think, leading to sapience and ability to think about thinking. And so in that sense, you know, I keep going back again to this same question, which would be what body is necessary to produce what kind of thought? You know, and Sonia, Ben, jump in here and correct me if I'm wrong, but it seems to me that one of the interesting aspects about the Sophia robot is that humans tend to look at it because it looks like a human, and we react to it as if we're actually somehow dealing with a strangely uncanny valley, but nonetheless human mind. And so I will present to Sophia robot if I spend 15 minutes or an hour talking to Sophia in a totally different way than if my trackball could talk to me. You know, if my trackball was as intelligent as you or Ben or Sophia the robot, and I had to talk to the trackball, it wouldn't be the same. I would get farther talking to my cat than I would the trackball, because I can have an empathic relationship with the cat, even if it's, you know, anthropocentrically transferred onto the cat. And so I think that that's very important in terms of the interface effect, Ben, right? I mean, we are conditioned by evolution to appreciate faciality. You know, and that's one reason why Deleuze and Guattari talk specifically about faciality in one of their books. We are built to react to faciality in a specific way. So what mind emerges out of the world where faciality is a fundamental aspect of the interface versus faciality being removed from the interface entirely? You know, again, I think that this idea of embodiment is fascinating because we are built by evolution to depend on certain forms of embodiment. But Ben, again, it would be great to hear you talk about this, because I remember thinking, man, what if the next robot that you do with Hanson Robotics doesn't look like a human at all? What if you can't empathize with it? What if it's a jellyfish? What if it's specifically designed to be 100% non-human empathic?
I think that humans can empathize with a lot of different things given the right set and setting, right? Like some people think of their cars and boats as almost people, right? And they may have more feeling, or their motorcycle, right? They may have more feeling for them than for the human beings around them. And of course, you know, some little kids get very attached to baby dolls that look human realistic, but some, I mean, I guess my 3-year-old is very attached to a little R2-D2. R2-D2 is not very human-like. It doesn't even talk. It beeps, right? It looks like a little cylinder. So, I mean, I think the human face and voice and everything that Sophia and Grace and these other robots have, they make it easier to get that attachment and bonding between humans and robots. And that's important, because in the attention economy, it's just hard to get anything going. It's hard to get people to pay attention to anything. So I think that's valuable, and that can be a way to pull people aggressively into positive emotional interactions with AIs and robots, when otherwise the big tech ecosystem is trying to pull them into much less positive interactions with AIs. On the other hand, I mean, I do think if you had, you know, a trackball, or let's say a rock. I like rocks better than trackballs. So let's say we found a way to make an artificially generally intelligent rock with some funky nanotech and all the molecules here, right? I mean, I think if that rock was wise and intelligent and funny and had a lot of cool things to say, we will learn to empathize with that rock more than with Sophia, right? So I think I like rocks anyway, so that's maybe too easy, but I think that having the human face and voice gives you a head start, but it's certainly not the only path. It's just one very interesting path, right? I mean, you could start with the cognitive side and just with theory of mind and deep understanding what the person is saying and thinking, and if you have enough of that, the body doesn't matter too much, right? But yeah, so we're looking at pet rock 5.0 to the singularity and beyond, right? So
in a similar direction to that organism you're just holding up in your right hand, I was wondering if you could think about AGI as an earth science, or what the proponents of that would look like. There used to be this, prevalent theory of the Gaia hypothesis, endorsed and deployed by people like James Lovelock in the 70s. But, this idea of the autopoietic planet, self-regulated through positive feedback loops. But I think now we're seeing a collapse of that model, maybe a phase shift, as Ed mentioned earlier. Today it was reported that Siberia has 118 degrees Fahrenheit temperatures on its land, 48 degrees Celsius. It's clear that like these carbon neutrality projects that like geoengineering and other terraforming projects are working on seem to like be regressive in a sense that we're trying to get back to this 0 point of carbon. And I'm wondering what AGI could perhaps point to in a different dimension of thinking about a science of the earth or a science of sedimentation and other deeper timescales.
Yeah, Lovelock, as you're probably aware, Lovelock in his own way was a big skeptic of the mainstream view on climate change and global warming, right? His view was more like Gaia is very rich and complex and big, and all kinds of crazy things have happened in its history. So you people are crazy to think that these little anthropogenic perturbations are screwing with Gaia. Now, if you're worried that humanity is causing changes that will harm humanity, like maybe so, but he's like you're barely denting the global mind of the ecosystem, so don't worry about that so much, right? And yeah, that's there's certainly something to that perspective, right? Like temperature has gone up and down many times, and distressing as it is, there's been massive extinctions of species many times. So if indeed we're triggering the 6th extinction, like that sucks. I don't want us to do it, right? But on the other hand, I mean, it's not like anthropogenic climate change is really going to extinct life on Earth or something, right? I mean, it's not major on that scale, although it is real, and extincting all these species is terrible. I do think that, yeah, all the things that we know how to do to impact the physical ecosystem and the chemical balance of the atmosphere and so on, all these things are very, very, very crude right now, right? And I mean, I tried to look at this from a data analysis view. So we have a paper on Earth Archive where we're just looking at causal analysis of global temperature change. And I mean, to be honest, I started that little data analysis project because I was sort of a climate change skeptic. I was like, these people are not saying that climate change is going to extinct humanity. Like if temperature goes up by 10 degrees in the next century, that's a long time. Humanity is gonna cope fine. I mean, not that it wouldn't maybe cause some death in the developing world from like people's shacks on the beach being destroyed. It could be but I mean, it's not going to extinct the human race, right? We're under way more risk from like nuclear holocaust or let alone AGI or nano gray goo or something. So I started getting curious about what the reality is, and we assembled these historical time series over the last 150 years of temperature, and then well-mixed greenhouse gases, changes of land cover, and then solar cycles and sunspots and various forcings from the natural environment. I mean, what we found is like by far the biggest driver of temperature change in the last 150 years is anthropogenic, right? I mean, it is in fact well-mixed greenhouse gases and deforestation that are the main drivers. So actually, the story that we are increasing temperature seems completely true, even if the scare stories about how it's going to kill off the human race are not true. Which is fortunate that they're not true, because we don't seem to be doing anything very impactful to slow down the anthropogenic increase, right? So it's that the extinction of a lot of species seems like it is happening, right? I mean, they're mostly very little species, but so we've been looking at what can you do with AI and machine learning to combat this. And so if you look at the carbon credit economy, one thing you can do is you can use machine learning based on satellite data and other sorts of data to estimate the amount of carbon naturally sequestered in a farm or a forest. so that then, without doing expensive soil samples, you can tell how much carbon someone is sequestering in their land, and you can give them carbon credits for it that they can then sell to BP or something, right? So you can do things that are of non-zero value using machine learning to help improve the carbon credit economy. But when you try to get deeper, you run into just practical issues of not enough data, right? So what we did with machine learning to look at the causes of global temperature change. So we'd like to do that in a hyper-local way, right? Like understand what is having what impact in which local ecosystem, and then what could you do to impact that most effectively? And they're just like collecting and curating all the needed data is very expensive, and the weather like there's not publicly available data from weather stations with enough spatial granularity to really do what you'd want to do. Like NASA's satellites that we're using for this carbon sequestration project don't cover the whole Earth, right? They only go on a certain path. Of course, there are probably like espionage surveillance satellites that are gathering all the data you'd want from everywhere, but you don't have that data, right? So like if hypothetically, like if we could send a swarm of nanobots around, or it doesn't even have to be nanobots, it could just be drones, right? But if you could send a swarm of things around to measure what's actually happening at a fine grain level with the global climate, it's entirely possible that data fed into an AI would tell us ways that are lower cost to reduce the impact of climate change, that would then save a lot of species from being extincted, right? And that would be quite interesting. No one seems to be interested in doing that. Whether the cost of that would be greater than just like building better houses for everyone living in waterfront areas in the developing world is another question I don't know the answer to, right? Because like in Hong Kong, when the super typhoon hit, no buildings were collapsed because they're very strong houses. In Indonesia and Philippines, when the same super typhoon hit, then a lot of people are killed and all their houses are plowed down, right? So there's more basic things you could do to diminish the human cost, but then there's also the cooler approach, which is like measure what's going on in Gaia and build AGI systems that are decentralized and interoperate with Gaia to shape the environment, which is really cool. And again, some people will say, well, this is mucking with mother nature, which it is. But I think I'm sort of with Lovelock on that, in that, unless we do something really nasty, like, pump huge amounts of nasty gases into the whole atmosphere or something. I mean, we're tweaking Gaia. Like there's a lot of depth and robustness in the like chemical ecosystem on the planet. Where this interests me even more is with like terraforming Mars and Venus, which is also like a mucking with Mother Nature in a big way, but it would be quite cool to make a human breathable atmosphere on Mars, right? And I think the methods that Carl Sagan and others outlined to do that would take just a couple hundred years. But could you find a way to fast track that, right? Could we be 30 years for a breathable atmosphere on Mars, right? Then certainly not unthinkable, but no one's putting much focus on that now. I guess my own line of thinking with all these things, which may be a bit naive or callow, is like, if we get the beneficial AGI first, then that system can solve these chemistry problems better than I can. Maybe it can even identify patterns from the current messy assemblage of global environment sensors that we can't pick up with our current narrow AI and statistics tools, right? But because the other disturbing thing I found when digging into climate science briefly is, so I'd been pissed off that all the recent climate models from the IPCC and so forth were evidently horrendously overfit to their training data. Like the standard methodology is make a climate model with a humongous number of parameters, fit to the data from the Earth's climate in hindsight, which is completely invalid statistical methodology, and then say you explained it, right? And if you did that in finance, you would lose all your money from your trading system. Like you can't fit the parameters of your financial market system in hindsight and then take that retroactive fitting as valid. You have to fit it based on one time period and then test it based on a later time period. And none of the modern climate models hold up to that sort of validation whatsoever. But what I found that was interesting is that the climate models from the 70s and 80s do. So like the pure, like simple thermodynamics climate models actually predict climate change quite nicely. And the reason they seem to give bad predictions is because when they extrapolated forth in the 70s and 80s, they were being overly pessimistic about the remediation that we would do going forward. If you feed to them accurate forward-going data about remediation, then you see these old thermodynamic climate models actually are pretty good at predicting global temperature evolution. The new models that have more parameters and more subtlety have gone downhill in predictive accuracy, right? So we don't have any really good fully featured models of our atmosphere and our ecosystem. I mean, the models are cool. They're fun for exploratory analysis. They're not usefully predictive, except in their basic thermodynamics like core, right? So again, could an AGI figure out a better approach to modeling? I mean, quite possibly. I mean, quite possibly the right humans could figure out a better approach to modeling, right? I mean, these are kind of simplistic differential equations models. I mean, Ed was going to mention Wolfram at some point. I mean, no one has built like the most sophisticated possible cellular automaton nonlinear dynamics model of the ecosystem incorporating all available data. It's just not something anybody cared about doing. So we haven't even plumbed the depths of what we could do in that regard now. But of course, an AGI could certainly do far better, right? And that's I mean, there's always trade-offs. I mean, an AGI is gonna pollute too by using a lot of energy, which currently is coming largely from fossil fuels. But yet that AGI also can probably learn to simulate and forecast what's happening with the ecosystem and design non-damaging interventions way better than what we're doing.
So I saw that Jose had dropped a question in the chat. Jose, if you want to pose that now, and then we can move to Randy after that.
Yeah. Hi. Thank you for the great talk. And also, I was wondering whether the general intelligence could be considered extrapolating features of our intelligence, which is what we know and what we feel the most. Features such as the politics that prompts the satisfaction of our care.
Yeah, I mean, as a very vague analogy, I look at it like raising human children, right? Like, I mean, you start off your kids with what you know, because what else can you do? Just throw them out into the crazy world on their own. On the other hand, in the more modern style of parenting, anyway, you're not wanting to make your kids into clones of yourself, right? You're wanting to give them the capability to learn and develop and grow on their own, and you're happy if your kids understand and do things you couldn't even conceive, right? And so that's sort of how humanity should look at the AGIs that it's building. I mean, of course, we got to fill them with human culture and values and understanding, because what else do we have? And of course, just like you would rather give more of certain of your traits to your kids and less of other of your traits to your kids, and you succeed at that to a mixed degree. I mean, similarly, humanity wants to give I would like to give some of humanity's traits to our AGIs more than other of humanity's traits to the AGIs. And I imagine we'll succeed at that to a mixed degree, right? But we also want to build the AGIs to grow way beyond this, just like we want our human kids to grow way beyond this. So we are giving the seed for a self-organizing system. And one of the things we don't know is how much difference does that seed make, right? Like there might be some attractor that almost any AGI we create will evolve into almost no matter how we start it, right? Or it might be there's a huge amount of path dependence in how we start that makes a huge difference in what will it evolve into. Also, what it will evolve into is one thing, and how it treats humanity as it evolves is another thing, right? So it could be that there's an attractor that will get evolved into by the AGI almost no matter how you start it. But certain paths to that attractor involve annihilating all humanity. Other paths to that attractor involve humanity living in bliss and utopia along the AGI's development path, right? So there's a tremendous amount of unknowns here, and rational thinking, narrowly construed, is of limited utility for some of these aspects because we simply don't have relevant enough data. There's big, like, abductive inference leaps that you need in order to deal with these things. So we're really forced to rely on intuition and whatever sort of cosmic insight we can dredge up, because rational thought is going to depend too much on large leaps from indirectly related amounts of data. I mean, not that I'm opposed to rational extrapolation whenever we can use it, but there's clearly, when you're thinking about what's something 100 times smarter than us going to do, there's a certain irreducible uncertainty from a purely rational perspective there.
Great, thank you. I don't know, Jose, if you had a follow-up. If not, we will move to Randy.
No, thanks.
Hello. Do you hear me?
Your answer.
Yeah, hey, so I have a question. Can you hear me okay?
I hear some good too.
Go ahead.
Yeah. So the architecture of Spencer Brown's universe, you know, this explanation according to what he calls the first distinction and this calculus of indications and all the technical details, right? The axioms, he builds this whole arithmetic, and everything can be described in all these different, everything can be stuck in there. And it makes like a much bigger universe because it's the ground from which other universes come about. So you can stick in all your multiverse things into this broadest framework of just making a distinction. You know, I mean, if you're into that sort of thing. So that presents a kind of architecture that involves at multiple levels and, and has like a real like structure to it. So I'm wondering, I know there's constraints on like the implementation of design, the coming into existence of these models of programming structure, architecture. But how close can do we want to like kind of approximate that structure and articulate what exactly are the specifics of that structure and how, representations or the presentations of the universe fit into that? I guess maybe just like this question. If so, there's that, and then I have like another one. All these models for artificial intelligence systems are built on like human child or like maybe a squirrel would be better for certain purposes, or a grasshopper or whatever for different
let me take the second question first, because that's an easier one.
Yeah.
I think there's going to be many routes to building human level and advanced AGIs, and certainly first building bugs and then squirrels and then dogs and apes and then humans would be an interesting and viable path. I think it's not such an easy path right now, just given the hardware technologies that are available. Like a number of years ago, I worked on building these virtual dogs in Second Life, and we taught them to play fetch and run around and so on. But I mean, in the end, you have to confront with that project like that what's interesting about a dog or a squirrel is really, really very much tied up with its physical body and its sensors and movements and skin and nose and all that. And if current virtual world technology your virtual animals are pretty lame, relatively speaking. So, but then to build like soft robots or like a squirrel or a dog, I mean, there's a lot of steps of mechanical engineering and material science and stuff to go through there. So I mean, building a robot with a body like a squirrel would be awesome and would be super interesting from an AI point of view. It's just that's not so much the direction that the robotics hardware ecosystem is moving in now. And then this becomes a tens of billions of dollar or hundreds of billions of dollar problem to start moving the robotics ecosystem in that direction. And U.S. government could do it. U.S. government throws trillions of dollars around here and there to bribe various investment banks and insurance companies. So I mean, U.S. government could put hundreds of billions of dollars into seeding a real soft robotics industry in the U.S., but it doesn't seem to have happened, right? So I think that is a very interesting point of view. I don't think that's the only path to human level AGI, fortunately, because it just doesn't seem to be the most practically viable one to do it at this moment, although it is quite interesting. I mean, along those lines, there's also like micro brains and like growing spheres of neurons in a vat and so forth. So that, I mean, that's also really cool. Like you, instead of soft robotics, you can try to grow the skin and grow the brain and so on. And I mean, that's sort of happening. It just seems like if you're going to do that research, there's a lot of steps before you get to the intelligence part. So I wanted to get toward the intelligence part faster. About laws of form, I mean, I was inspired by that back to the 80s when I discovered that book and started corresponding with Lou Kaufman about it, who I more recently have gotten to know. He's an awesome guy, and he's done a lot to advance that line of thinking. I mean, one thing I'd want to point out, though, is when you study computer science and logic, you find there are very many like universal formalisms for computing and universal formalisms for math. So like the fact that you could build up everything out of Spencer Brown's distinctions is really cool. I can also build up everything out of combinatorial logic. I can also build up everything out of cellular automata. Like there's a lot of cool formalisms that you could use to build up everything out of them, and which one to choose for which purpose becomes an art as much as a science. And you may end up choosing one from the purpose of theoretically analyzing what you're doing, and choosing another from the purpose of architecting a practical system just because of the practical and like engineering properties of the medium out of which you're architecting that practical system. And that's sort of where I'm at with laws of form now. Is I find it very interesting and inspirational in terms of deriving certain AI algorithms or reasoning engines and thinking about like what's the right framework for knowledge representation in OpenCog. Like it's an interesting formalism to use for deriving approaches. In terms of implementing systems, it doesn't necessarily seem like the best formalism to use for implementing like efficient AI algorithms running on current computing hardware. That may be bad, and maybe because current hardware sucks, right? But that's what we have to work with. So I wrote a paper called Paraconsistent Foundations. Actually, two papers that the title begins with Paraconsistent Foundations. One's about classical logic, one's about quantum logic. They're both on the arXiv and with my name on them. And one thing I show there is that Spencer Brown's waveform logic, as developed by Varela and Kaufman, it's equivalent to Anna Patterson's version of paraconsistent logic, which is called constructible duality logic. And then I build a morphism between an uncertain version of constructible duality logic and our probabilistic logic network, so we have an open cog. I then show an approximate morphism accurate up to an arbitrarily small error between uncertain paraconsistent logic and quantum probability theory, right? So you can map quantum logic into paraconsistent logic and into laws of form. So there's mappings between all these different ways of looking at things, which I think need to be plumbed more deeply, right? So I would say how useful laws of form is for creating, say, inference control engines for guiding uncertain classical or quantum reasoning engines. I'm not sure. Like these morphisms that are articulated in these papers from late last year give a way to think about that, which is cool, and that's a promising research direction for sure. The only cautionary note I wanted to give in the beginning of this reply was the fact that you can build up everything out of laws of form is really cool and beautiful, but it doesn't distinguish it from a lot of other formalisms that you can build up everything out of. Like there's a lot of ways to build up the universe, which is very cool.
It seems, Ben, that that's connected to the kind of argument that Wolfram makes to say that we need to go below math, and he offers, of course, his own new kind of science to go below math. But essentially, what you're saying is there's actually
Spencer Brown does a way better job of going below math than Wolfram did, I would say. Yeah. Although Wolfram's universal computer cellular automaton, which was really come up with by someone else working for him, and there's a whole legal mess about that. But that's another story. But yeah, he apparently that CA rule was come up by someone else working for Wolfram's company, but then Wolfram sort of didn't want that guy to get the full credit for it, right? Which was interesting, and there's two sides to the story, I'm sure, but that whole paradigm is cool in a way that CA rule, whoever really came up with it, is kind of a hack, right? And it's a nice hack. It's good. I'd be very proud of it if I'm the one who'd come up with it, right? But I think you can get to universal computing from laws of form and paraconsistent logic and so forth in a much less hacky and more elegant sort of way. But the aspiration is related in both cases, right? I mean, the aspiration is, you want to go not just below math, you want to go below math, below mind, and below the physical world, and you want to go to like a core ontological cosmogonic level or something where you're building up all these things from nothing. And this ties into the Buddhist logicians, Dharmakirti and Dignega in the 1500s, who had their own way of building everything out of nothing, which if you squint enough is basically also morphic to laws of form. I mean, they're looking at the consciousness as a basic act of distinction. They build up to like 128 different states of consciousness based on a set of binary distinctions, and that's they're trying to build up phenomenology at a very fundamental level to where individual human minds and the physical world are both sort of these patterns of binary distinctions that come out of different states of consciousness recursing on themselves, right? So this, which comes out of I Ching generally, not the fortune-telling parts of I Ching, but the deeper parts of I Ching that are less frequently translated into English, that go over how these patterns of binary distinctions build up everything in the world. So you go I Ching, then into Dharmakirti, Dignega, then Leibniz, of course, read I Ching, which is what led him to make the first version of propositional logic and what's now called Boolean logic, and what led him to formulate the universal characteristic, which was the first attempt in the Western world to make a sort of logical foundation of everything. And laws of form is a beautiful, very elegant step in that lineage. cellular automata are another beautiful, elegant step in that lineage, which have more of a dynamic aspect to it. So I think, yeah, this is all very deep. And the reason I wanted to root this in Dharmakirti, Dignega, and the I Ching is to show that the original roots of logic, like before the modern era where logic became really mathematical, I mean, the original roots of logic actually were wrapped up in phenomenology and with going below mathematics, mind and physical reality. Like that's where logic all began before it became so much a pure, like, quantifier pushing endeavor in the 20th century. And this relates to the use of logic in AGI systems. Like a lot of people are down on logical AI systems. Like, we just need to build neural networks that learn from experience. We don't want to do logic because logic is bad. It's purely symbolic and isn't grounded. But actually, logic is supposed to be grounded, and logic was grounded in experience in its prehistory in the I Ching and Buddhist logic and Leibniz and so forth. I mean, actually, logic originally is grounded, and it sort of drifted away from that a bit. And with use of logic in systems like OpenCog or NARS, I mean, logic is going back to its roots in phenomenological, perceptual, and experiential grounding, right? So Ed, I actually have to go soon. I only had 2 hours for this.
Okay, very good.
Amazing concept fest here. But I could
Do you
probably
have a couple more minutes?
do one more question if there's something.
Yeah,
something
Colin, you had your hand up, Colin. Do you want to jump in right there?
I did, but it's a hard time, and I'm not sure if it's fast. So if you want to move into closing remarks,
I can give
or
a
someone
true or
else has
false
something.
answer to anything.
That's
all
great.
right. Yeah.
Thank you.
Okay. Well then, Ben, I guess, Colin, maybe we can loop via email. Does that sound good? Okay, super. Ben, thank you so much. This was fantastic. You know, one of the things I always hope is that the hundreds or thousands of really long roads and rigorous paths that you've walked down can be rendered visible to people when you present your work. And so I think quite a bit of that came through today, which to me is it's always a tremendous learning experience for me. I would hardly say that it's riffing with you, but it's really like it's a tremendous learning experience for me. And the notes that I take give me years of material to dig into. Specifically, the Buddhist Logicians one is one that I'm going to go down for.
Yeah, so
quite
there's
a
a
while.
book by T.H. Skarbatsky called Buddhist Logic, and this is a Russian guy from the middle of the last century. It's not the easiest book to read in the world, but it's once you get into it, it's beautiful. But that's the best review. I mean, it's 2 volumes. It's a long review, but once you go through that review, then you can dip back into translations of Dharmakirti and Dignega directly and better understand what the hell they're talking about. But it's amazing because they themselves were summarizing like thousands of years of development in that domain, and they got deeper into the analysis of phenomenology of consciousness than anybody has since, right? Like we haven't yet replicated that, just because that's what they cared about, and we care about that less, right?
It seems to me that, you know, I think it was Sonia who had brought up one of the questions about embodiment, and it seems to me that is also a point to loop back through questions of what it means to define the body, not just as a human body, which we can recognize as a human body, but a very, very complex assemblage, part of which is a recognizable human body and part of which extends across a range of different networks and temporalities.
Well, a fun thing to do would be to take the structure and the dynamics in something like OpenCog and Singularity Net, and then in a robotic body, and map these into the ontology of consciousness states from Dharmakirti and Dignega, right? Like which consciousness states are rendered more accessible by having which aspect of a body, right? I mean, one could do a whole PhD thesis of this sort of mapping actually. So yeah, there's a lot there, and yeah, I would like to thank you actually for encouraging me to dig into Deleuze, which I've done in the last. You and Weaver are the ones who have pushed me deeper into that, because I sort of I got into Baudrillard for some reason, because his book Simulations and Simulacra was too cool, but and Foucault, because he had more concrete stuff to hang on with the analysis of schools and mental hospitals and sexuality and all that. But I sort of originally was turned off to most of the postmodernist philosophers just because their way of speaking is so contorted and gotten my nerves. But you sort of nudged me to reread Difference and Repetition like 5 times, and I mean, after reading it enough, you get used to their weird way of expressing themselves also, and you let go of the idea that a word is supposed to mean the same thing each time the same guy uses it in the same book, right? And I mean, there is a lot of phenomenological insight in there, and they are getting beneath the individual mind, math, or the physical world in a certain way that others were not. And I think there's some unique contribution there to the task of like understanding what minds and worlds are. I mean, certainly there's a lot of other connectors needed to connect that to actually practically building and teaching systems. But there's something quite interesting. By the way, did you ever encounter a book on the origin of objects?
No, I don't think I have.
Brian Cantwell Smith. So this is from maybe 20, 30 years ago, but he's looking from an AI point of view at how does the notion of an object ever come about. But that's one of the more that ties in with a bunch of Deleuze stuff, but in a more modern cognitive sciencey way. So I think there's a lot more threads there that can be connected, and the more of these threads you can connect, the more of overall human culture and history you're pulling in to the practical task of building AGI and catalyzing the emergence of AI. And I think as screwball and destructive as some of human culture and history is, I still have an intuition that the more of it we can pull into the task of building AGI, after all the constructive and destructive interference happens, I mean, the more of it we pull in, the more likely we are to get like a beneficial AGI singularity, which is what we're both pushing on.
That's what we're working on. Yeah.
But on that note, I must
you must adjourn.
Thank you so much, Ben. Thank you, Ed. Ben, thank you for letting us pepper you with questions here at NSPDOS. It's been a blast. I think everyone else, as I see them nodding.
This was Ed's events are always very cool, just because you get brilliant people who are deep thinking about stuff that's relevant to my universe, but yet coming from a different direction than the people I usually talk to. So yeah, thanks.
It was very fun.
Thanks everyone for chipping in, and I actually had intended to have a more rapid back and forth dialogue. I always end up rambling for too long. But
no, that was great. That was great.
Thanks for putting up
Thank
with
you,
me.
Ben.
All right.
Thanks, everybody. Everyone. Thanks, everybody. Thanks, NPDOS. Cheers.
Thanks, Ed.
Thank you.
Thank you.